That's Toad the Wet Sprocket. If you were around for class, you remember that one. 80s band. Well, 90s band. Still band from Southern California. Here it is. Circles. We're talking about circles. Everything is about circles. Started off. The first learning target of the day, of the week. Be able to speak and write. So that means you got to kind of be able to talk about it. Got to be able to write about it. Got to be able to describe it. We got three things here. We got chords, we got arcs, and we got central angles. You might notice and wonder a few things here, or you might not, but you can see the circleness going on here. Circles going on, more circles. But we know a lot about parts of the circles already. You know about a diameter. You know about a radius. See spokes of the wagon wheel here. A little more today on the menu. We're putting a little more on your plate, and that's really some of these other things, like over here, these bars on these windows. Never seen a round prison cell, but we're talking a little bit more of those kind of things. And we're talking about how we make angles from the center of the circle out. We make angles from points on the circle to other points on the circle. That's our discussion. So let's just jump right into it. Here we go. It is number one. We've got chords. What is a chord, you say? It is 2 points. You can see it. 2 points. Always 2 points. Attached in a line segment. Straight line. Across the circle. It may go through the center. It may be a diameter. That's possible. But not all chords are diameters. But all diameters are chords. The ones that aren't, you can tell why they're not. It's pretty obvious because this one goes outside the circle. This one has a name, it's a radius, but it is not a chord because it only goes halfway across the circle. And this one went just a little bit too far. It went outside the circle. Remember, the ends have to be on the circle. So if I adjusted that and I put the ends on the circle, then it would be a chord. All right? So be careful, that last one's a little tricky. Chord, not a chord. Rewind and play as many times as necessary, but we are talking about what a chord is. All right. Vocabulario number dos. We've got arcs, and arcs we're talking about. You can see what an arc is. You're going around the circle, but we're really looking at it as a degree around the circle, not the length yet. We will talk about arc length coming up in, lesson 7, 8, 9. But right now we're really looking at it just like we would look at a central angle, and that just didn't come out right at all. There's your central angle. So if you're talking about this angle in here, if we knew that angle, the arc would be the same thing. So if that angle, let's just guess and say it's 120 degrees. That means the arc as well is also 120 degrees because they both go around in a complete circle being 360. If I have to go over here and take a little guess at this one and say that central angle was 30 degrees, that means the arc would also be 30 degrees. This one's kind of obvious. It looks like a diameter because it is a diameter. As long as I can draw a diameter. There we go. So that central angle is 180 degrees, and the arc associated with it. And when I say associated, that really just means connected to, or connected. So that arc and that angle are equal. Associated arcs and their angles are equal. Down below, not an arc because it's not a circle. And this one, that's not an arc, it's a chord. So it totally belongs in the last section. So there we have it. That's what central angles are. Their vertex is the center. So you can kind of always remember that. If you think about a central angle, its vertex is the center of the circle. And then we move on to the next one. Central angles. Wait a minute, what was I talking about? Oh, sorry. I was talking about central angles. These all go together. So central angles, the vertex is the center of the circle. Arcs, kind of associated together. So let's just wrap this up, this discussion here. Let's say that's a central angle right there. It goes through the center of the circle. Center. Central arc, central angle. We're talking about arcs, though. We're really talking about this angular motion along the outside. So we're talking about arcs, we're going around here. Central angles on the inside. And if it's not through the center, it's not a central angle. It's got to be through the center of the circle. So the vertex of that central angle has to be the center of the circle. And its associated arc is still equal. So if that's still a 180-degree central angle on the right there upper, then that arc is also 180 degrees. If this angle over here was, let's just say it's 95, the angle on the inside is 95. Those are the same, they go together. Little exercise here we did in class, we were just kind of playing around with, well, what happens if we do a little bit of proof? Please remember that the word proof, you've got to really prove, you got to know your stuff here. First thing, connect the radii, because there's the center of the circle. If I connect these guys, that actually makes life a lot easier, because now I've got some information. I've got DE is equal or congruent to BC. That's because they told us that's given. But then I've got all the A's, AE, AB, AC, and AD. All those line segments are congruent. Why? Because they're all radii. Radii. Radius, 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 radius. 4 radiuses equal 4 radii. So now I've got a situation where I've got equal angles. And actually, I don't have any equal angles yet. That's what I'm trying to prove. I'm trying to prove something about the arcs and the angles. Well, if I look at these triangles, they have 2 equal sides that are connected, and they have a third equal side right there. So they are congruent. So the triangles are congruent to each other. And if you want to say that specifically, for this triangle AED is congruent to triangle ABC. Why? We're going to go with the big old side theorem, because they have 3 corresponding congruent side lengths. And then once those are equal, then the angles are equal. Then you say, okay, well, those triangles are congruent, therefore the angles of the inside, those central angles, are congruent. If the central angles are congruent, then the arcs also must be congruent. And that's just a little bit of proof. We have to kind of, when they say explain your reasoning, I know people always explain your reasoning. That's my reasoning, folks. That's it. I'm going after these triangles being congruent. If triangles are congruent, every part of that triangle is congruent. And that is arcs, chords, and central angles. A little bit of a summary here. You can stop and read this, but they're really just doing the same thing, talking about what a chord is, what a central angle is, what an arc is, and a little more information. And with that, we'll call it a day for lesson 1. See ya.